My name is Matt Bishop. I work with Adaptech. Adaptech is a CQRS event sourcing consultancy. It's founded by Adam Dmitruk, who has created the event modeling framework. He's been working with Greg Young, who's famous for the CQRS architecture, and Nicholas Tixtrazi, who is the CTO of Adaptech. The three of these guys have been working together for 10, probably 15 years now to work on CQRS as a concept and working with clients to build out systems that use CQRS and event sourcing. In the course of the progress of this work, Adam has built out a concept of design called event modeling. If you're familiar with event storming, you can think of this as taking it to the next step or the next level. Event modeling creates an information blueprint that can be used by teams to build out software systems using what you see looking like this in more detail, of course, but for the most part, a single view of the information system and the components that need to be built out therefrom. It's a collaborative design process that involves everyone in the business. It's workshop based. So the workshops usually run between 3 and 5 days, depending on how much there is to discover and how much the company or the client wants to build. Involves an infinite whiteboard, stickies and pens, or digital whiteboard. We found that when a workshop starts with the physical, it invariably ends up going into a digital whiteboard, especially over time, to allow for communication across larger groups of people. Editing over time, it becomes that place you go to look for what is being done, what has changed, what's coming next. It's an open board, so everyone gets to add to it and edit it. And in the process of it, it feels fairly chaotic because there's a lot of people who don't normally make software or describe software working together to create the event model for their business. We try to bring in the people who own the business, who run the business, who operate in the business, who use the tools that the business uses to do their work. If there's any subject matter experts that need to come in, we'll try and bring them in, and of course the developers who are in charge with actually building the system that comes out of it. In the real world, it looks something like this. You got stickies on the wall. The organization of it, I'm going to walk you through, but it's very intentional, and it's part of the workshop is to go through several steps of process to come to an organization of the elements that you see here. There's 7 steps. I'll walk you through these steps now. These are not a waterfall set of steps. They generally group together and then so follow the steps for a while, and then you go back and refine as you discover new things or you make decisions or you decide to make some changes. But the board itself or the blueprint itself goes through these stages before you come to the completion of it. Okay, the first one is called brainstorming. This is a step where you really try and draw out of the participants what it is the business does in terms of events. So you use this time to teach the participants what an event is, the concept of something that happened in the real world. Is something that's happened in the past. It's an unalterable, immutable state of fact. You can eat a taco. Taco eaten is an event. You can't uneat a taco, right? That's just something you can't change in the world. And so that's what events are. A lot of times you spend a little time as well talking about observations versus state change events. State changes are the ones we're interested in. Observations are things that occur, but they're not really relevant. So for instance, oftentimes you'll see people put up what they think of an event as customer entered store. That's an observation. It happened. You don't need to record that. That doesn't change the state of the system. So it's not really an event. But customer made a purchase. That is a state change that's interesting to the information system that we're modeling. After you've discovered the events, or a lot of the events, or a good set of them, then you move on to the next stage, which is creating the plot. The plot is where you introduce the arrow of time, and you explain that things happen in a sequence, and you are trying to find the sequence of events that lead to an end goal. So they discover the end goal, and then often you work backwards from there to line up the events as they occur, so that you can find what the plot is. You may find there's more than one plot, and that's fine. You make more than one, but you really try and get the events that have been discovered in a row or in an order that tells a story. Because what you do next is you build out a storyboard. The storyboard connects these events to artifacts or applications or processes that the business uses to execute their work. So these aren't high fidelity mock-ups, they're wireframes. The processors are basically, steps where somebody makes a decision, or a system makes a change and makes a call out or does something along the way. But it tells the story of the events, but using props, if you will, or artifacts that they're actually going to encounter in their actual use of this application or this system. From the storyboard, you then work out the inputs. Now, this is an interesting step because up to this point, people who are coming to this believe that these user interfaces, these processors, generate the events directly. And this is where we talk about these commands and how a command is an intent to make an event, but it's not a guarantee. And there are handlers that listen for, that take these commands and check them against the state of the system and verify that it is okay, according to business rules, for this to occur. What you want to provide to the business or the information system is events that are trustable. You believe they are correct. You don't have to validate that they should have occurred. That's what commands are for. So commands can be rejected. It's a request to make an event, and they are in blue. So each one of these will be a handle or a piece of code that will look at the events that have occurred to determine the state of the system as it is now, look at business rules for the shape of the data coming in from the inputs, and use those to create the commands. So you'll notice that we have lines directly from the screens to the events. We use this to capture the fields, those information fields that we are showing and capturing data from in the user experience. We want to tie those into the commands and events so that we have traceability. You know where this data came from because you can follow it back to the input that it came from. Similarly, we talk about outputs. So when these events have occurred, what happens next? So the things in green are called views. A view is, sometimes they're called aggregations, or there might be a projection or a read model. These are output data frames, if you will, that are going to go to other systems. So in this case, you can see there are frames being used to render calendars, to-do lists. There are frames that are being sent to processors to do external operations. Those external operations then feed back down with commands to do whatever they need to do to describe. They can also be output syncs, like a report at the end, like a sales report. These views are computed solely from events, and they produce data. They do not actually generate SQL or HTML. There is another piece that listens for that and translates it out. So you're trying to keep this pure and data and very functional in what you're designing. After you got these done, then we do what we call apply Conways Law. So Conways Law, if you remember, states that the organization of a business is reflected in the architecture of the software that they produce. And what this means is the way that the teams are composed determines the architecture of the system. That's not something we find to be ideal. Teams are often composed by for reasons that are more political than relevant to the tasks that are at hand. And so also teams are often composed around silos of capabilities. So the team that handles one part of the system handles for all parts of that. and that doesn't actually line up very well with what needs to be done as far as the events and the timeline is concerned. So we use swim lanes to organize these by specialization. So along the top, the swim lanes are organized by the actors, the people and the systems who are actually going to be utilizing those outputs and generating the inputs. So for instance, like the very top one, you'll see there's like a checklist and a form for rooms and cleaning. These are different actors, and they have their own specialization. Along the bottom, you've got a registered row. You've got the payment requested row, payment succeeded row. This one is a specialization based on the type of information that's happening. So you can assign those to different teams, but you know which ones go together by these swim lanes. And then the last major step is elaborating the scenarios. There are 4 kinds of scenarios. There are state change scenarios, state view scenarios, external state input, and external state output. The state change ones are basically follow the given when then. Actually, all these follow given when then or given then. So it makes them very testable. But in this stage, you're basically lining up what the rules are for how a state transition will occur given the events that are occurring ahead of time. So you're basically making requirements. You can't book a room for a guest until the guest has been registered and the room has been added. Pretty simple, but these are those business rules, right? A sales report requires paid events to compute or to go into the sales report itself. External state input and output are interesting because the external state input one, especially, you're using external events that happen outside of the CQRS system and turning them into events that are inside the system. So GPS updates. We have a feature in this particular story where you say, when I leave the room, or when I leave the hotel, I want you to clean my room. So we need to identify from your GPS on your phone when you actually leave the hotel. So those events are occurring. The blue sticky there is coalescing them and deciding, okay, now I'm going to generate an entered hotel or exited hotel event based on this input coming from the external system. So you use these 4 types of scenarios and you line them up for all the state changes, all these different things you have to keep track of based on the events and commands and the views that are associated with them. So events, commands, views as asynchronous APIs is something I've been interested in. We have seen some cases where this is useful and others where it doesn't help as much, but because this is an Async API conference, I really want to talk about how you would do this in Async API. So the basic idea is you publish commands and you subscribe to events. So if you're familiar with Async API, there are basically 2 types of channels, 2 directions. The commands channel and the events channel are line up with the blue and the orange stickies. I didn't use the right colors because it's a bit bright. Some of the good parts about this approach, we're using asynchronous calls to receive and send these, is you can do a fire and forget strategy where you want to send commands. You don't really need validation that they occurred. Whatever effect they have is whatever the effect is going to be. You're not really that fussed, so you're just going to do it. So a good example of these, the user interface events like mouse moves, the GPS tracking is another one. You need to send these commands quickly, but you don't really care so much if they actually do anything. You're going to use the views to compute what you can do next based on what the views come back as. It's also useful for one or more delivery. If you run certain of how fast your system is going to be, or you really need the command to occur, you can fire the same command multiple times down the asynchronous channel, and then listen for the event channel, and then do your own matching. So events have a causation ID that lines up with the command ID, so you can use those to determine if the command was successfully executed, and you can know that the system is going to ignore all the subsequent commands that match that command ID. So it's a good way of making sure that your commands are actually getting through. There are some downsides to this, which are you don't have a call response approach to give you failure feedback. So if a command fails because of business rules, you have to have a channel for that. It's not here, but you can imagine an errors, or maybe the events channel has an error event coming through. But you have to design a way to track, if you care, if your command failed. If you do care, then the causation linking is on you, and it's a little harder because you're going to have to keep track, right, of what you've sent as a command and what events have come back. If for some reason your application goes offline and you come back, out of the box, Async API does not have a concept of catching up. You have to build that protocol into your API yourself. And some people are apparently doing this, but it's not part of the spec to do this. So that's a couple of the downsides of using Async API for publishing commands and subscribing to events. The part I like a lot about Async API for event modeling is the views. Views are naturally a subscribable source, and it's really nice because views by definition are current state only. They don't have the notion of replaying what you've missed. When you subscribe to a queue, the data you get is the most current view. It's not sequential in nature where you have to replay through. If you need to have something like that, then that's part of the view itself. These are data-centric objects, so they send out data, and then a listener will transform that data into what their endpoint needs to show. So it could be you need to update a React view or React model. It may be that you need to generate a PDF file and drop it in a hot folder somewhere. You may need to make a SQL call to update a database. Whatever it is you need to do, there's a separation between the view subscription and the reaction to that data that comes down the view at that endpoint, which is good for serverless architectures. Okay, so event modeled, how does this look in the actual Async API code? So I'm going to switch over to a small project I've written called Hotel Management API. It's a WebSocket project. You can use obviously the protocols, but I'm familiar with WebSocket, so that's what I've been using for this. The channels I've created, one is called, sorry, I slid past, is the register channel or the guest channel with a register command, and it's a publish because you can publish commands, and its headers contain the data, the metadata about the command. I'll show this in a minute. But the payload is simply the data, the information you want to capture that's business related. So the user wants to register, they get to get the first name, their last name, and their email address. Matching it will be the registered event, which you can subscribe to. Its headers are again the same as far as they're a separate concept. Its payload is identical to the command. This is very common. It's not always this way, but I'd say 90-95% of the events that are created by commands have the exact same payload as the command itself. In a way, it makes sense because a command is a request to create an event, or it's a request to make a state change. And most of the time, you're just checking in the command handler, is this allowed? You know, if I'm trying to delete an account, is there an account to be deleted? Or do I have, you know, the rights to delete the account, or whatever your business rule is that you have to enforce at the command handler? You're making a yes or no decision, should this event occur? And so the data would match. Like I said, it's not always the case, but it's often the case. And so it's really nice that Async API lets you do references like this to that data. You can also obviously put these in components. That might be a better case, but just want to make the point about this data being the same for most cases. I've got a book guest command, and it looks very similar. It's got a guest ID, booking ID, check-in dates. So it's nice having the JSON schema format to define the payloads. And guest book, as again, has a reference to the book guest command. A note about the operation IDs. These names are look more like what you'd expect from the coding side. And so I think there is some tooling that would generate out classes that use the operation ID as the object name or the class name for the data in this payload or in this message. So that lines up really nicely with a generated program model coming from this specification. Views are a little different. We're past it. A view, I use a parameter to describe what hotel I want to subscribe to the views. In the commands, I didn't use these. Commands, as I'll show you in a minute, often have in their metadata header will have the entity ID that describes what entity is being operated on with this command. Hotels are more query based. You don't want to see all the hotels, perhaps you just want to see this hotel. So it takes a parameter. These obviously can be more than one kind of ID parameter, whatever you need it to be. It's up to you to decide. The payload has some similarities to the events. One thing I want to note is you're going to be creating views to serve or view data to serve the views specifically. So this particular view wanted the guest name to be full name as opposed to first and last name. The reason, I don't know why, I'm just pointing out that the data you get in the event doesn't exactly match the data you send out. So what you don't want to do is refer to properties on the event in the view model. You want to basically separate that relationship between the event data and the view data, because you don't want that that hard link between the two. Views are easy to write. Views are standalone. They are not really supposed to be sharing data references directly to the events, and so this is a way to show this point. It's a string. How you compute full name is something you put in a note with the view definition itself in the event model, but it doesn't show up in the Async API. And then the components. So the shared headers, I should probably start at the end and go backwards to explain. Shared headers is command headers, and it's basically all the shared headers plus a command ID. The event headers are all the shared headers and the event ID, which shows it's essentially the same thing. It just has a different ID. Their types are even the same. They're both UIDs. But again, the semantics of what they're for make all the difference as to why they're the same, yet they have two different types for describing what it is they're for. So the shared headers, you have the entity, which is the thing you're operating on, the thing in the real world, the key. So how do you identify this hotel from that hotel, or this guest from that guest? The actor, we've talked about actors in the event modeling framework. This is the person who is, or the role that is actually executing this command or executed this event. Causation ID, this is how you can trace. This is very similar to other eventing systems. Command that generates an event, the causation ID of the event is the command ID. Correlation ID is, you can send down correlation IDs, and that covers a set of commands and events. So you could create a saga with this, or some like a batch job, something large you want to group together multiple operations, state changes, view responses. All these things need to be grouped together by a correlation ID. This is something that you can pass it down through in the event. The only two that are required are entity and key. The others, you could obviously grow this to make actor required, but causation and correlation are also not required, but they may need to be part of your system if you obviously have to have them. Okay, so this is really cool. I'm going to generate, I did this once, but I'll do it again, using the Async API tooling to generate a Node.js project, and it's thinking about it. This is quite exciting for me. This is sort of the payoff of one of the big payoffs of doing this is a generated source. So if I go into the API and I look at the handlers, right away you can see I've got command handlers generated that will accept that command and generate out the event. This is, or write the event into an event store. So this is really nice. Here's that operation ID I was talking about before. For views, you've got basically when the events come in, you can populate your view from that. You will often obviously inject other lookups to the event store to get data from other parts of the system to populate your view. This is a way to coalesce multiple events together. But this output creates the routes and the WebSocket and everything you need. That's not it, sorry, to get started on building out your system. So this is a really nice tool set and a good reason to use Async API to create these event model systems. So thank you for your time. I think we're going to be taking questions. If you have further interest, please visit these sites. There's a nice Slack on Twitter. A Slack channel. There's a link here. If it's in the slides out, you can go to the eventmodeling.org website and find the same link there. And then you can follow Event Modeling on Twitter and start learning more about this exciting way of developing event-driven, event-sourced CQRS systems.